All right, IBAASL2. We're off and running with our stats unit. So today we're going to talk about mean, median, and mode, or which are also called measures of central tendency. So measures of central tendency. You guys have probably seen mean, median, and mode before. Please remember that mean is just another word for the average. I might as well say it up front that we're going to be using X bar or mu for the average. Mu is like not an M, it's like a Greek letter. But that's what the average, oh, I said it right there. Way to go, Jolly. Starting off the video right. The median is the exact middle piece of data when arranged from least to greatest. So sometimes they give you a data set that's not ordered, and then you have to order it first in order to find the median, which is the exact middle. The mode is the number of data that occurs the most. You can remember that because of mode starts with a mo, and most starts with a mo as well. First problem, some people were surveyed about how many hats they own, and then it was put into a frequency table. Remember that these are how many data pieces of that kind there are. So it means that there was 3 people who had 0 hats, and like 1 person, nope, I'm getting it backwards, sorry. There was, no, that's right, 3 people that have 0 hats, and then there's 7 people that have 1 hat, and then 3 people that have 2 hats, and 3 people that have 3, and 2 people that have 4. So, we need to figure out what is the mode of this. Well, if you picture all these numbers out in a row, it's like 0, 0, 0, 1, 1, 1, 1, 1, 1, 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4. So this is the mode right here. You just look for the number that has the highest frequency. So the mode is 1 because there's 7 of them. Some common mistakes that people might have here. Some people might say that the mode is 7 because it's like the biggest number, or that there's 7 of those numbers, but the actual numbers in the data, there's no 7s in the data. It's just 0, 1, 2, 3, 4. So the 1 is the mode. The other thing that people might say is they might say that the mode is 3. This is also wrong, but I see why they're saying that because they see 1, 2, 3, 4 different 3s in the data, but that's not what a frequency table is. The data is just 0, 1, 2, 3, 4, and then the frequency is how many of each of those types there are. Next up, the age of students who exercise. So people were asked in this school what their age is and if they exercise. So if they did exercise, they got recorded into this data table. So this means that there was 2 students between the age of 13 and 14 that exercised, and then there was 6 students that were between 14 and 15 that exercised. So these people aren't exactly 13 or 14. It's like, oh, I'm 13 and a half, or I'm 13 and a quarter, or I'm almost 14 sort of thing. So it's like their ages are decimals. If we're going to find the modal class, you still just look for the highest frequency. 10 is the biggest frequency, so that means the modal class is just that interval. It's 16 all the way up to 17. Also, while I have your attention right here, this not putting the or equal to here, a lot of statistics books would write this with the inclusive part on the bottom of the interval, which is fairly standard across the board, but for some reason your book switched it and they started doing the alligator or equal to on the top. So please know that from here on out, we're still going to follow the book and keep the or equal to on the top part, like all the problems in the book do. But this is the more statistician way to do things. It's better for a couple different reasons, but like I said, we're going to stick with the book's notation, but just know that, if you actually go into a real stats class, they'll want you to do it the other way. All right, the mean is the sum of the data values divided by the number of data values. So you add all your values together and divide it by how many there are. Another way to say that is that x bar is equal to sigma x over n. Sigma x, if you don't remember, sigma is an adding machine. So it adds together all of the x's. It's the sum of all x's. All right, the first example we're going to do with finding the mean is the age in years of 10 pet cats. So 10 cats were surveyed, and each one told the person how old they were in meow. Find an estimate for the mean age. Okay, the way you want to do this is you're going to add a couple columns to this. First of all, the ages are in intervals. They're not actual solid numbers. So what we have to do is add on a column that's called mid-interval value, but I think of it as midpoint. So the midpoint between 0 and 2, if you add 0 and 2 together and divide by 2, it's like the average of the interval, is 1. And then directly between 2 and 4 is going to be 3. Between 4 and 6 is going to be 5. And between 6 and 8 is 7. Then we need to add another column. This midpoint you can think of as M. We are going to add an FM column, which is frequency multiplied with the midpoint. So 2 times 1, like if you multiply those together, you get 2. And then if you multiply 4 and 3 together, you get 12. 3 and 5 is 15. 1 and 7 is 7. Then we need to add some totals here on the bottom. The first thing that we need is a total frequency. So we're going to add all the frequencies together. So that's 2 plus 4 is 6, plus 3 is 9, plus 1 is 10. So that means sigma f is equal to 10. This is the sum of all the frequencies. That there was 10 cats in the survey. We knew that from the beginning. I love that somebody's out there with a microphone just like talking to cats. Like, excuse me, sir, how old are you? We have to total up the FMs as well. So this is sigma FM. 2 plus 12 is 14, plus 15 is 29, plus 7 is 36. So then your mean is going to be sigma FM. It's the total of all the midpoints times the frequencies added together, divided by the total number of data, which is sigma f, all the frequencies added together. So this is 36 over 10, so this is 3.6. So that means the average cat is 3.6 years old. Next up, Will scored an 85, 93, 92, and 84 on his 4 tests. Will's real nervous about keeping an A in the class, and there's one more test, so we need to figure out what he needs to score on that 5th test in order to keep the average at 90. Well, let's add together all the scores he already had. I almost don't care what his average is right now. We're just going to take those 4 scores and then add a 5th score that we don't know. Let's call it X. And then when this is divided by 5, he needs to keep a 90. Then we need to unlock that X. So multiply both sides by 5. That means this side is going to be 450. And then if you add 85 plus 93 plus 92 plus 84, you get 354. So this is 354 plus X is equal to 450. So then subtract subtract 450 by 354, and you get 96. So he needs a 96 to keep his 90% average. gosh, that average is going off the rails. Let's start over. Find the median of this. Okay, let's talk about medians. I think when you were first probably trained on medians, you were told to put all the numbers in order and then cross off numbers from the left and the right in pairs. So like cross off the 1 and the 18, then the 2 and the 17, then the 4 and the 16, then the 7 and the 12 and the 9, 11, then boom, here's your median. Median is equal to 10. Now, the way medians can get more complicated is if we give you a very large data set. You don't want to be, first of all, you don't want to order it and you don't want to cross them off. It's just not the best way to go about it. Oh, also with that cross-off method, if it had come down to 2 numbers in the middle, it would be the average of the 2 numbers in the middle. So medians in general, if it's an odd data set, then you just take n, so n is your total frequency for the data, and you add 1 and you divide by 2, and that'll tell you which data piece it is. That does not give you the actual median, it just gives you the location of the median in terms of the whole data spread. If you have an even set of data, like an even number of data, then you have to average the 2 middle ones, and the 2 middle ones are the n over 2th and the n over 2 plus 1th. Allow me to show you an example. Find the median of this. So, first thing we need is how many data pieces there are. So, I'm going to make a bottom on my table here. And then actually, we're going to need one more column. If you add 35 and 15 and 21 and 7 and 40 and 9, you get 127. So, sigma F equals 127. So that means there's 127 pieces of data in this data set. So if I go back up to here, that means that I'm using odd because 127 is odd. And then if I do 127 plus 1 over 2, 128 divided by 2 is what, 64? So that means the 64th piece of data is the median. The way you figure out where the 64th lands is with something called a cumulative frequency column. So this is cumulative frequency. The way you make a cumulative frequency column is it's like a running tally of how many data pieces you have. So in the first row, you have 35. But then in this spot right here, you have to add 35 and 15 together to get 50. Then you have to add 50 and 21 together to get 71. If you keep doing this, 71 plus 7 is 78. 78 plus 40 is 118. And then the very last one should always match up with your cumulative frequency. So this should be the sigma F. Now, the reason you do this is so you can figure out where the 50th or the 64th piece of data is. If I look at the first column or first row, all 35 pieces of data in the beginning are all ones. Then the 36th through the 50th are all twos. So the 36th piece of data is a 2 and the 50th is a 2. Then the 51st piece of data all the way through the 71st are 3s. Now 64 comes after 50 and before 71. So we know that the median is here. So the median is 3. Whoa, spell it right, Jolly. All right, you guys, that's all I have for you. Come ask me questions during class if you need help with anything.